Hi everyone, my name is Vincenzo. I work in research at L2s. And today the talk is about data availability risks and how to make a DA layer secure, looking at it through the lens of the L2s DA risk framework. So to start, data availability is crucial for L2 security. Nodes need data to reconstruct the state and advance it. And this is important for both kinds of constructions, both for ZK constructions or optimistic constructions. And the reasons differ slightly. For example, for an optimistic rollup, you may have a malicious state root posted to Ethereum, and you need the data to compute the fraud proof and invalidate it. While for ZK constructions, you may have a correct state being posted to Ethereum, but without the data to prove the ownership of your individual assets, your funds may be frozen. And if you take into consideration also the possibility that the malicious operator may ask for a ransom to make the data available to you, funds could be stolen also in the ZK case. And so, since the risks are critical, how do we make a DA layer secure? And the first thing to consider is economic security, which is definitely not a meme. And it is important for liveness, so to make sure that the data can enter the ledger, so there is no censorship on the DA layer. And also for safety, so that once the data enters the ledger, is not reorged away for a deep reorg. And this is the current state of the DA layers listed on L2s. And you can see that there are some projects that have staked assets, but slashing for non-attributable faults like data availability withholding attack, for example, is very hard. In Celestia, for example, you would need a social fork, which is expensive and hard to pull off. For Eigen, you would need a token fork. But the takeaway is that most slashing mechanisms are still untested, and some are still under development, like the Eigen one. So how do you protect against the most crucial kind of attack in data availability, the data withholding attack? You need data availability sampling. And this is in production for a couple of projects like Celestia and Avail. But the assumption of data availability sampling is that there is a minimum number of light nodes on the network that are sampling this data. And this is very hard to verify. So if you're working on it, come talk to us. And another thing that is very hard is the block reconstruction protocol. So once these light nodes sample all the data, you want them to be able to communicate peer-to-peer and reconstruct the full block, so data is not lost. And this is still under development for most projects today. But the DA layer is only one side of the equation, a secure DA layer. What's also important is to have a secure DA bridge. And so for an external DA that is maybe used by an Optimium or a Validium, you need Ethereum to receive a proof that the data was made available on this external DA layer. And this proof then needs to be relayed to a smart contract on Ethereum. And this smart contract is called a DA bridge. And without this bridge, Ethereum has no proof of data availability. So it is very important, and a DA bridge needs to be integrated in the proof system of the L2. Today, there is no DA L2 that integrates with a DA bridge, which is pretty bad, but hopefully that will improve soon. So briefly looking at what makes a DA bridge secure, because we looked at the DA layer, but what makes a DA bridge secure is three main things. You need to look at the community security. So who provides the attestation to this bridge? Is it a small committee? Is it a big one? Is it your friends? Is it a validator set? Then you need to look at relayer failure. So who can relay the DA attestations, and what happens if it goes offline or turns malicious? And also bridge upgradability. So are these attestations immutable, or can someone change the history commitments of these DA attestations? And you can see from the red on this slide, also there is a lot of work to do on DA bridges. And if you're wondering about DACs, because so far we're seeing external DA layers, but there are also data availability committees. And there are many of them. Some are better than others, but you can get the full list on the L2Beat website. And if you want to find out the more details about this risk framework, you can find it on the L2Beat forum, and you can scan the QR code to get to the link. And since I have some time left, maybe I can say that DA layers, as you've seen, have different characteristics, different risks. So despite DA being cheap and some people saying DA is a commodity, I think it's important to look at these differences and actually take seriously the risk that may come up from using external DAs. And that's it for today.
Applause, please. So it is more than important, and thank you for summing this up so nicely in short minutes. Of course, we could talk about this and we need to talk, right? So please, questions. We have 2 minutes for questions. Where do I throw this? Maybe you can just say from your perspective, from the background that you have, like in the risk management and these kind of things. How do you see the state of this today? Right?
Yeah, these projects are pretty new, let's say. They launched mainnet maximum a couple of years ago. So there's still work to do, and teams are serious, so they're working on it. Right now, we have the risk framework to kind of get the state of how things are at the moment. And there is no project that is all green, because they just started, let's say. I mean, they've been working on it for a long time, but mainnets are more recent. But I'm sure they'll get better soon, yeah.
You have faith.
Of course.
That's good to hear. Did anybody thought about any question? No? Yes? Please, raise your hands. Yep. Please use the microphone so the people on the internet can hear you as well.
Yeah, so in your slide you said that EigenDA use DA services and others are public blockchains. So could you give more comparisons of these different kinds of DAs?
Yeah, in the slide I showed DA layers. So we divided in 2 sections on L2Beat. We have public data availability providers and custom. So in the public ones, we have public blockchains like Celestia, Veil, and also EigenDA as a DA service, because it's a public layer that is meant to support many projects using it. While on the other section, you would have data availabilities committees that usually are deeply integrated with one single L2.
Okay, thanks for the question and for the answer. Thank you, Vincenzo, again, and thank L2Beat to everything that you guys are doing.
Thank you.
Thank you.
Thank you, guys.
So, applause, please, for Vincenzo.